Today, I'm going to be teaching you geometric progression, a sequence in which each term is obtained from the preceding term by multiplying or dividing by a constant number or term is called a geometric progression. Let our A be our first term and our R be the common what? The common ratio. The sequence A, comma A times R, comma A times R raised to the power of 2, comma A times R raised to the power of 3, and so on, is called a geometric progression, in which the first term is equals to what? A. The second term is equal to A times what? The common ratio. Then the third term is A times R raised to the power of 2. Then let's say the nth term is equal to what? A times R raised to the power of n minus 1. The reason why it is n minus 1 is that the index of R is 1 less than the what? The number of term. Now here you will see that the power of R is 1 less than what? The number of term. So that's why the n term is equal to A times R raised to the power of n minus 1. Now, let's solve this question. You can see on the board. If the first, second, and last term of a GP are 4, minus 20, and minus 12,500 respectively, find the number of terms in the GP. Now, you can see from the question that the first term is equal to what? 4. And we were told that the second term is equal to what? Minus 20. And the last term here is minus what? 12,500. How do we find the common ratio? We can find the common ratio here because the first term and the second term was given. To find the common ratio, we divide the second term by the what? By the first term. So we now have our common ratio, which is R, small letter R, to be what? To be minus 20 divided by what? 4. So if I divide this, I'm going to get minus 5 as a common ratio. Now, the question goes further to say, find the number of terms in the what? In the GP. So, to find the number of terms in the GP, I'm going to represent the number of terms in a GP to be U subscript of n. You can decide to use any letter. So, to be equal to what? A times R raised to the power of n minus 1. So let's go further to solve the question. So here, our A is 4 from the question. That is the first thing. That is 4 times. Then our R is minus 5. Raised by what? N, because we don't know our n. Then that is the number of terms. Minus what? 1. is equal to the what? To the last term. And what is the last term? We have minus 12,500. So here, I'm going to simplify this. I can decide to divide both sides by what? By 4. So if I divide both sides by 4, I'm going to have minus 5 raised to the power of n minus 1 to be equal to, if I reduce this to lowest term, here I have 3, here I have 1, 2, 5. So I'm going to have 3,125. So minus 3,125. Then minus 5 raised to power n minus 1 is equal to, I can write this in index form. Minus 3,125 can be written as minus 5 raised to the power of 5. Because minus 5 raised to power 5 will give me minus 3,125. At this point, we equate the powers since the base are the same. So this will go. So we have n minus 1 is equal to what? 5. So collecting like terms, we now have n is equal to 5 plus 1. Therefore, n is equal to 6. So at this point, the number of terms in the GP is equal to what? 6. So please, if you find this video helpful, please subscribe to my YouTube channel by clicking the button below. Thank you.